Okay, so I show you all the question again. I think it's good learning for everyone. If you were to see questions like this, can see my screen? Yep, y'all might want to take a screenshot. So this is the flame we are talking about. The air hole is partially open. Partially open, this is like fully closed. So you have a yellow flame, okay? And then flame C, this is where the air hole is fully open, okay? And then this is for B, right? There's a partly burned ring, and then the center part is actually not burned. Explain why there's an unburned center. Now you know how to explain this, because right in the center over here, okay, it is actually unburned gas. It is the least hot. Whereas the outside, right, okay, is actually the charred part. All right, because it's hotter. And then these are actually carbon remains. For this particular one, why is it so black? Because this is incomplete combustion. The yellow flame is due to incomplete combustion. It burns with a lot of soot. So it is actually the deposit of the soot on the paper. Clear? Okay, not that it burned up. No, it didn't. But it left behind a lot of carbon, which is soot, S-O-O-T, okay, on the paper. All right. Then because it is the this part here, okay, this particular paper was placed over the Bunsen burner with the air hole totally open, it is extremely hot. So when it's extremely hot, it burns up. Any more question on this? Okay, I hope there's no more question on this part. Right. Somebody's here. Let me just enter this person. Let's see. With you is here, Rachel, Dina, Charmaine, Hayin. And then I'll quickly take your attendance. Who is this person? Okay, hi, Amanullah Muhammad. I don't see your name actually on my list. I can't hear you.
So can you hear me now?
Yes, I can hear you now.
Okay.
I don't see your name actually on my list.
But like the 8-day tuition, they told me that I can attend this class.
Right. Is your name Aman?
Yes.
Oh, okay. So A-M-A-A-N.
Yes.
Is that the name that you have here? Okay. All right. So this is you. Yeah. Thank you.
They didn't teach us light in Sec 1 yet.
Okay. Yeah.
So I couldn't do the worksheet.
Did you watch the video in the e-learning portal?
I can't access it.
You can't access it. Okay. Right. How many of you cannot access the video? Let me know. Were you able to watch the video in the e-learning portal? You can, and you did, right? Yeah. How about Dina? Dina, can you? You can access it. Rachel? Rachel is also new here. Rachel, were you able to access the e-learning video? I cannot hear you, Rachel. Now, Aman, then you have to try again. You have to try again. Okay, you usually can watch the video, right? In e-learning portal.
No, I can't watch any video.
Right. Did you subscribe to the e-learning? Thank you, did you?
I used to be a subscriber of
And then you stop with that.
Yes.
I see. Okay, thank you. Okay, you know, so if you're not a subscriber, you cannot watch it. Yeah, so okay, that's why you can't do the worksheet. Never mind, because we started on this topic last week. Okay, so this is actually the second worksheet for light. Yeah. Okay, so we will learn along the way. Okay, you learn by going through the question. Anyway, I'm going to quickly run through the slides once more before I go into the worksheet questions. Yeah, so for Rachel and Arman, yeah, you have to watch or you can take a look at the slides very quickly. Yeah? If you have your textbook with you, it's in 1B. 1B, the first chapter. Okay, you'll be good if you have your textbook with you. Okay, I actually saw some of your responses. Many of you still did not complete the second part, which is the open-ended question. Correct or not? The structured question. Hey Yin, you actually did the worksheet last week. Okay, there's a new worksheet, you know, that is updated. Hey Yin, can you log in quickly and get the worksheet now? Can? Yeah, otherwise you will find that, you know, you cannot follow what we are doing. Because I asked for quite a number of questions to be taken out because it's not in your syllabus. Yep, only Heiyin did the worksheet on 1st of April, and that was the old version. Okay, the rest of you are assessing the correct one. It's only like 14 questions, right? Good. You got all correct after.
No, what happened was I didn't know how to do some parts of question 13, and then I went straight to question 14. Then I tried to go back and do some, but the question 14 didn't save.
Ooh, okay. Oh dear. Can. Never mind. So when we go through later, if you want to share your answer, you'll be good. Okay, because the previous lesson, I have one more lesson, right, for Sec 1 that is on Thursday evening. So they did ask me to check their answer. And then when they typed into the chat and I saw their answers, right, I told them they're not going to be getting any marks. Okay, because sometimes you thought that you have answered the question, but actually you didn't. Okay, let me share with you. Now, let us very quickly go into the slides first. Okay, it's a good recap. Okay, so this topic, what do you need to know? Okay, you can see my screen? Give me a thumbs up. Thank you. So very quickly, let's take a look. Okay, Aman, you can take pictures if you want to, take screenshot, yeah? Okay, so these are the things we need to know for light. You are expected to know all this, reflection, okay, and then how it is being affected by different surfaces, characteristics of image formed by plane, mirror. We also learn about curved mirror, right? Okay, so effects and uses of reflecting surfaces. That is the part when you have to describe the convex as well as the concave mirror. Describe some effects and consequences of refraction. Okay, so it causes us to see things to be shallower than it is in water, for example. Okay, then dispersion of white light by a prism. Then explain how we see color of objects in white light as well as colored light. Then compare speed of light, sound, and common moving objects. So you have to know that speed of light is actually the fastest, the greatest out of this three. Okay, so how do we represent light? Okay, the rays are usually drawn in straight lines with the arrow pointing the direction is moving to. Okay, so you have to indicate the arrow is important, okay, especially when there is reflection or refraction. Speed of light, okay, know of the speed, okay, 300,000 kilometers every second, or if it's in meter per second, then you need to know how many zeros there are, okay? Then reflection, okay? Ray that comes in, hits the surface, it's called the incident ray. And then when it gets reflected, it's called the reflected ray. Regular reflection. Okay, this happens when light actually hits a smooth surface.
So can you go to the previous slide?
Oh, so sorry, you haven't taken the screenshot.
And also the one before the speed of light.
Right. This one.
Yes. Okay.
Okay. Okay. All right, Aman. You can watch this recording also, after today's lesson. Yeah. So we talk about regular reflection. Okay. Light hitting a smooth surface. All right. So the incident ray comes in parallel. When they are reflected, they are also parallel rays. Okay, so this is regular reflection on a smooth surface. When light hits a rough surface, we have a diffused reflection. The next slide will show you a better example, right? Okay, so look at the light. They all still come in, and gets reflected, all right, following the law of reflection, but they are now scattered in many different directions instead. So if you look at the next one, okay, take note. Every incident ray that comes in hits the surface, obeys the law of reflection. All right. What is the law of reflection? Incident. Okay, this one, this angle of incidence and the angle of reflection is actually the same. This is the law of reflection, right? So you need to draw a normal perpendicular to the surface that is reflecting. Then you have to draw the incident ray as well as the reflected ray, showing that the angles are exactly the same. Okay, each of them follows the law of reflection. But then because of the uneven surfaces, the reflected ray are all scattered. So you get a blur image, all right? Or you can't see the image at all. This is the example. Okay, when the water is calm and still. Okay, this is like a very smooth surface. So you get the image very clear, very sharp and nice. Then when the water is rough and then there's wave, okay, this causes a very rough surface, right? So reflection is blur, or in this case, you can't even see it. Okay. So this is the meaning. All right. You need to know characteristics, okay, of image formed on the mirror. Is upright. Just imagine yourself standing in front of the mirror. Okay. Your height is the same. Your size is the same. Okay. When you are 1 meter from the mirror, your image is 1 meter after the mirror. Okay. It's virtual. It's not real, right? It's not captured on the screen. You just see it in the mirror. So it's laterally inverted. Okay. Left appears as right, vice versa. And then reflecting surfaces. This is how we make use of it in daily life. In your worksheet, you're asked to state examples, right? Explain. So later I'll tell you what is the meaning of explain. Did you just state it, okay? Or did you explain how come you're using that? Okay, it's important, huh? Now, so you look at convex mirror, it shows you a wider area, okay? But then, okay, even though it's wider area, it's actually a smaller image for all the objects inside. Okay, and then concave mirror is the opposite. When the dentist is trying to look at the inner side of the teeth, it shows an enlarged image. Okay, enlarged image. Okay, so this is another example when we have the candle over here. Okay, concave mirror. If the candle is too far away,